So in today's lesson, we're going to solve for the principal angle. But before we do that, let's actually recap a previous example we did in a previous video. So we have a point -6, 8, and which forms the terminal arm. So let's sketch the terminal arm, which is over here somewhere in quadrant 2. So you have -6 and 8. Put here 8. So I'm just going to draw this over here, and I'm going to draw this -6 and 8. Next thing we're going to do is calculate the 6 trig ratios. So start out with sine theta, cos theta, and tan theta. Now keep in mind, theta is the angle that is going to push the terminal arm into the quadrant 2. So we're going to use this triangle, which is pushed by the principal angle into quadrant 2, to figure out the trig ratios. So let's look at this. So sine is opposite over hypotenuse. Now in this triangle, we know that this here to here is 8, and from here to here is -6. Now the hypotenuse, we need to figure this piece out by using the Pythagorean theorem. A squared plus b squared is equal to c squared. I'm not going to do that. I'm just going to give you the answer right away. Now sine theta is going to, referring to the triangle, is opposite, which is 8 over 10. Cosine is -6 over 10, because this is your adjacent. I'll put here A, and this is OPP. And the next one is going to be tan. Tan is going to be OA, which is 8 over -6. I'm not going to bother reducing. To get the other 3 ratios, the cosecant, which is the reciprocal, we just take 10 over 8. Secant, reciprocal of cos, which is -10 over 6. And tangent, cotangent, which is the reciprocal of -6 over 8. Now just to recap, there's another way to get these ratios, but instead of starting with the diagram, we can start off with this. So recap that xy of any point on the circle is r cos theta and r sine theta, and what's given is these two pieces are given, and we can calculate the radius, which is 10, to figure out the cos and sine. But I'm not going to go over this method. You can look at a previous video. All right, so now let's solve for the principal angle. So the principal angle, as you can see here, is theta, 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 theta. But in order to solve for theta, we need to take the inverse of sine, the inverse of cos, and the inverse of tan. So let's just write down the following. I'm just going to write down exactly the trig equation. So right now, these are trig equations because there's an equal sign and we're solving for an unknown variable. So I'm going to write these out again. And what do you think we're going to do to figure out the theta? So we're going to take the inverse of all these pieces. So the first one would be inverse of sine, which is going to be 53 degrees. This one here, we take the inverse. So inverse, just to show you that it looks like this on your calculator. This is going to give us 127. Now, inverse of this number here, inverse of 10, is going to give us -53 degrees. Now, the issue right now is, let's look at the picture. Always go back to your diagram in this diagram here. This is our theta. Now, out of all these 3 answers, which one do you think is the one that fits your picture? Let's go through the first one. This is in quadrant 1. Keep in mind, this is 0 degrees, 90, 180, and 270. That's why this is quadrant 1. This would not fit our picture. Now this one here, I believe this could be a winner. 127 is between 90 and 180, and I believe that this fits. So I'm going to put the next there. -53. Now I haven't taught you negative angles yet. So what's happening is, we usually go from initial arm counterclockwise. Now when you have a negative angle, instead of going counterclockwise, we're going to go backwards. So we're going to go backwards -53 degrees, and this indicates we are in the quadrant 4. But clearly our picture is in quadrant 2, and therefore our principal angle, I'll call it P8, is 127 degrees. So the issue is, Miss, do I have to go through every single one to make sure that one of my answers fits? No, you don't. So let's just say you did the first one, you got 53 degrees. Well, if you notice something, 53 degrees is related to 127. When you add them together, it actually gives you 180. So let's look at 53. So let's draw 53 over here. So 53 is in quadrant 1. So from here to here is 53, but I don't want my answer to be in quadrant 1. I want it to be in quadrant 2. So now you're going to have to take your principal arm and go all the way over to this side. This is what we want. However, we know that this little piece here is a reflection of this principal angle of 53. So we know that the related acute angle, so keep in mind these are RAAs, And how are you going to get this angle here, the principal angle? Well, we know that from here to here is 180, and then we go backwards. In other words, we can take 180 minus 53, which gives me 127 degrees. So in this case, we had to rely on our picture. So over here, I'm just going to draw it over here. For 10, it gave us an answer in this quadrant here, 53. But we know our answer is in quadrant 2. So we know that this angle here, all the related acute angles, keep in mind related acute angles are the angles that are next to the x-axis, they are all the same. So keep in mind, we want to look for this terminal arm from initial arm to all the way here. So we get exactly the same step as the first method using sine, but we're just starting off with a different quadrant. So we're going to solve for the principal angle given a specific point, but I'm not going to ask you to find all the trig ratios. So let's actually draw this point here. 5 root 3 is it's positive, and n negative 5 down here. So we know that this point here is in quadrant 4. So let's just draw the triangle. So I'm going to draw the principal angle. Principal angle, keep in mind, is an angle that starts from 0 degrees. Initial arm goes all the way here, pushes the terminal arm into quadrant 4. So this big curvy thing is the principal angle. Now this principal angle creates a right angle triangle in quadrant 4. Now let's have a look. So this piece is going to be negative 5. It's the y value. And this piece over here is going to be the x value. So you have a positive x and negative y. And over here, this is the radius of the circle or the hypotenuse, but we don't really want to waste time solving for the hypotenuse. In this case, we have the opposite and we have the adjacent. And we're going to be using OA. In this case, tan theta is going to be equal to negative 5 over 5 root 3, and you reduce, you get 1 over root 3. Now, this is one of the special ratios that you should have encountered in previous videos, or a teacher may have taught you, or some people will use a calculator, take the inverse, and when you take the inverse, you get negative 30 degrees. And you're probably thinking, oh, I'm done. Well, miss, isn't this correct? Well, isn't negative 30 degrees, like you said in the previous slide, oh, I go backwards, I go a little bit backwards, and I'm in quadrant 4. And isn't my point in quadrant 4? Shouldn't this be the answer? Well, you are partially correct, but you have to look at this little thing that I'm circling. This means that your angle, your principal angle, has to be positive. So instead of going backwards, we can actually go forwards. In this case, we're going to go, so we know that this little piece is 30 degrees because we went backwards 30 degrees. So if you want to change the negative into a positive, you can actually go a full circle and then go a bit backwards. That means 360 minus 30 is going to be 330 degrees. So this would be your final answer. Now, if you notice, we got two different answers, but they actually end up in the same quadrants. There's actually a name for these two angles, so they look different, but they end up in the same quadrant, same terminal arm. These are called coterminal angles. So since we're talking about coterminal angles, for example, if I say 0 degrees, and if I want to come back to the same spot, well, keep in mind, if you go a full circle, a full revolution, you end up getting 360. You end up in the same spot. So let me show you. You have 0 degrees here. Imagine an arrow. And if you go one big circle around, we end up in the same spot. But this 0 degrees can be considered the same position as a 360. So if you want to find coterminal angles, all you have to do is take the angle of interest and add on 360, 360, 360, because when you add one full revolution, you end up in the same spot. Do you always have to add 360? No, you can actually go backwards 360. So if I went backwards, so backward means to go this way. In this case, I get a negative 360 degrees. So these three numbers, they're coterminals, they look different, but they end up in the same spot. So if I took the answer from before, negative 30 degrees, I can just simply add 360 because I'm going to end up in the same terminal arm in quadrant 4, end up getting 330 degrees. Or let's just say you can go backwards. Instead of negative 3 plus 360, you can subtract a full circle backwards. You end up getting negative 390. So they look different, but they actually mean the same position in quadrant 4. All right, let's move on to this last example here. So we got this, as you notice, our numbers seem to be the same, but the signs are switched. Now, where is this point here? Well, it's in negative over here and positive. So we have a terminal arm in this quadrant, and I'm just gonna Draw this point here, and from here to here, this is in quadrant 2, that's your principal angle. So now we have the hypotenuse, which we don't have, but we do have the opposite, which is 5, that's your y, and you got the x. So we're going to use, again, tan. We got the OA. This is your opposite, this is your adjacent, and we end up getting the same ratio as we had before. So this one here looks exactly the same thing as this. And if you do the same thing on your calculator, we end up getting negative 30 degrees. Now, keep in mind, negative 30 degrees is in quadrant 4. But we know that these are reflections of each other, or opposite angles of each other. In this case, this angle here. And keep in mind, all the related acute angles with the x-axis are always the same when reflected. So that means we know that this little piece is 30 degrees. So, but I want from here to here. But if I go a full 180, but then I go backwards 30 degrees, I end up getting 180 minus 30 degrees, which equals to 150 degrees, which is between 90 and 180. So when you do these questions, as I said, the calculator may not give you exactly what you want. You just have to adjust to the restrictions and adjust to your picture. So here we're going to generalize. Instead of using specific points, just call it x and y. Now x and y can be anywhere in any quadrant on any axes. So over here, let's actually look at the following. So let's look at this one here. Let's actually start out with quadrant 1. It doesn't really matter where it is. So imagine this is your x and y, a point on the circle. This thing that I'm drawing would be the radius of the circle. Now how do we calculate the radius? Well, keep in mind there's a triangle embedded. This piece is your x, this piece is your y, and we're going to use, to find the radius, we're going to use Pythagorean theorem. So c squared is equals to a squared plus b squared. In other words, r squared is the same thing as x squared plus y squared, or you take the square root and you have this. Now keep in mind that the radius of a circle is always positive. In order to have a circle, you need to have a positive radius. So now let's look at the specific trig ratios at the bottom here. So sine, now sine is going to be, remember we talked about sine is related to y and cos is the x? It is no different here. So in this case, let's look at our picture here. Well, we want sine. Sine is going to be the opposite over the hypotenuse. In this case, it's going to be y over r. Or we can actually replace the r with that thing that we got from Pythagorean theorem. Sine is the adjacent, it is the x, so it's going to be x over r, or we can write it as x over the square root again. Now tan, what is tan? Well, tan is opposite over adjacent, or like in previous videos, it is y over x. And these ones over here, the reciprocals, you just take the flip, so I'm not going to bother doing that, you can do that on your own.